Hi, I'm Rick,
Hi, I'm Armand.
and welcome to part 2 of our Azure Digital Twins series, right? Our trilogy on everything you need to know about Azure Digital Twins. And today is about onboarding your building into Azure Digital Twins and querying,
Yes,
among
exactly.
other things, right?
Yes, especially. Yeah.
Cool. So take it away.
Yeah, thank you. Let's get started immediately then. So last time we talked about setting up your model.
Yep.
So that's cool. Now we have a model in our twin. So what I can basically I can go to our Explorer or Digital Twins Explorer.
Yep.
And I can see my models on the left-hand bar. Well, currently I've already uploaded a test building, but normally you would see an empty world.
Yeah, so the only thing you see then is the models that you modeled, that you created in JSON,
Yeah.
that you uploaded with the tool that you showed last time.
Yeah.
But then there's no building or structure yet.
Yes, correct. So there are no twin instances or nodes yet.
Better, yeah.
Yeah, exactly. So to even give you a quick head speak on that, in this viewer there are two ways of looking at stuff, at your twins and at your models. In this case, this is what is there, which is a link between your models, but this part will be empty.
Okay.
So now we want to, of course, put actually stuff in there. And the first way of doing that is going here in the Explorer, press a model and say add. That's fun, but that won't scale.
That's fun for like 5 minutes.
Yes, exactly. And
then you have to do a building with 1,000 devices and then...
Yeah. Even then, if you have to do 1,000 devices, automation is sometimes already boring. So let's still get to that.
Yeah.
So in that case, what you can do is onboard it via code. So in this case, what we've did is I've created a very simple console app that is basically going to add a building with a few floors and a few spaces underneath it. The reason why I choose three types is because I want to show a little bit how you can change in onboarding.
Mm-hmm.
So if we look at the code, the first thing we see is just using interactive browser credentials to log in, because I will only run this locally. Of course, when you upload this, use managed identity or the default Azure credentials.
Yep.
And then I add the building. So I subtracted the logic to add a building into a different function, just for clarity. And in this case, what I'm doing is I'm using the Azure SDK, to be specific, the Azure Digital Twins SDK, which I use to generate the Digital Twins client. Then I'm also using from the SDK the basic Digital Twins or Digital Twin class and the basic Digital Twin component class, just to create instances of it. So these are basically helper classes that you can use to fill up all your properties. So in this case, if you look at the code itself, you see that I define an ID for the twin, the model what it is, and then I just start adding stuff to my contents, which is a dictionary of string object. That is cool that we did the first part. But if you want to also add a component, then we can just create an instance of the helper class basic digital twin component. And there we go. We can also add values there. We add it once again. And we call create or replace digital twin async.
And then that actually just calls out into an API that runs on Azure to create the digital twin in your instance. Yeah,
it's good to know that the digital twin itself is basically a complete HTTP platform. So everything goes over HTTP calls, which also means that you can use that API if you want via Postman or any other tool for yourself. It's also possible to do this via the AZ CLI. There is an extension that you can install, and then you can also do this via there. Practically, the reason why I'm showing you code is because I think that's the most used way of doing it so far.
Yeah, and especially if you want to do like, give me 1,000 of these, then you'll just write a for and it'll upload. And otherwise in Azure CLI, you'll have to
automate your scripts. You can do the same.
But then again,
bash.
Yeah, true.
The important thing here is that like I mentioned, I do a create or replace. So the thing here is that if you create a twin which already exists, it's literally going to override it. And that is just a given. So you have to keep that in mind, that if you want to add stuff. So the ID collision is really up to you. So if you don't want to have any collisions or override by accident, you have to verify your IDs first.
Okay.
Yeah. So in this case, when I've added that, I have now one twin. Cool. Then the next step would be, like we saw in the previous code, I go into a for loop and add a number of floors. Well, if I start adding floors, I'm doing it a little bit differently. So I'm now not using the helper class, basic digital twin anymore, but I've written my own class. So I've written a class called floor, And as you can see, there are some properties that you might recognize, so like the ID and the metadata.
Yep.
The reason why we recognize them, because if we go in, we have to specify that those JSON property names do match with what the twin is expecting. So basically I wrote a wrapper around it, and as soon as it gets serialized, it will still turn into the actual proper properties. That being said, I'm still using some helper classes because I don't have custom metadata, so why should I? We do the same way of adding it, so it's create a replace again, and then finally we add our first relationship. And in this case, I'm also using a basic relationship, which is also a helper class. I provide the ID, which is it can be anything, can be a GUID, it can be anything random if you want to. However, they need to be unique, so it's up to you to make sure that it's unique. What we tend to do in a lot of cases is adding the source, /, the target, and then the relationship name to it. In practice, that's almost always unique.
I can imagine, yeah.
It's an easy way of recognizing your IDs.
Just one quick question, because I know the upsert or the create or replace that you specified here. Some tools implement that if you do a update, but you only provide, let's say, half of the properties, it only updates those properties. Does this actually replace the entire twin?
Yes. It will basically, overwrite everything from object level.
So if you want to update just 2 or 3 fields, don't
do this.
Create or replace with only those 2 or 3 fields, because the rest will be gone.
Yes, exactly.
So that's important to keep in mind.
Yeah. In that case, we'll get to that. You want to patch.
Okay.
So the same goes for relationship. Also, now we're talking about that. It's good to mention about that. And when we're adding relationship, we also have to, of course, define the name. Like we mentioned, it's an entity itself, and we've defined the different types of relationships. So in this case, it consists of, and then we do the same thing, create or replace.
Okay.
And once again, it's also important to know that basically all these basic classes can be replaced with your own classes. They do expect certain properties to be there when you serialize them, but that can be done with the JSON convertings. Yeah, and eventually I just add a space here, and I do some magic with setting some values if the ID is a certain value, because we need that later on.
Okay.
But that's for demo purposes.
Okay. Just for the people watching, will this code be, or is this code available on like GitHub or somewhere in an open repository?
Currently not, but we can definitely make it open.
Okay. Well, that might be interesting for people to be able to just look around what you did, how you did it.
Yeah, definitely.
Cool.
And it's also good to mention that everything that I show here, especially like the C# kit, is also well documented. Even if we aren't there yet with putting everything online, you'll find it anyway.
Cool.
But that's basically how you onboard a building. So if I would run this, it would create a complete twin structure. So let me quickly do that. It won't give much feedback because I didn't implement any console logs.
Yeah, but we can probably see when it's done, right?
Exactly. So if I now would go over to our ADX and I would start pressing run query, I would expect, there you go, we slowly see parts coming by. So it's actually slowly adding more.
And you can see that it's growing. That's actually pretty nice.
So that's proof that the code works.
Or that somebody somewhere else in the building is now frantically adding.
But you didn't see me wave, so there were no signs.
That's true.
All right. But that's basically how you add a twin or multiple twins instances.
Nice.
So, but then when you actually put them in there and you want to change one, you use JSON patch.
I could go to the portal and just change it there, right?
Yeah.
But again, meh.
Exactly.
You don't want to do that.
So indeed, right, we have this nice UI where I can just change it. But in the background, this is actually the front end here is translating that to a JSON patch and then sending it. So this viewer is nothing more than just transferring some stuff into API calls. But the reason why I wanted to show JSON patch, right, that's used to update stuff. So for the people who aren't familiar with JSON patch, it's the idea is that you have a JSON structure where you describe what needs to happen. So in a specific case where you want to add a property, you define that you want to add a property, that's the operation. You want to define where to add it and what to add in it. that's one of the options that you have, but you can also replace stuff, remove stuff, or override it. And that's how the twin itself is also using it. So you just create a JSON patch, fire at it, and done.
Okay, cool.
So it's rather straightforward forward into that. But then, once we have updated everything,
We'd like to see what we did, right? We want to have some type of querying mechanism.
exactly. So if you look at this view, you probably already see that I have this beautiful select star from Digital Twins.
Yeah.
That's the basic query that there is, the simplest form of a query. And in this case, I can just run it and I'll get everything back. So that's cool. However, there are some more complex queries that you can do. So first off, right, it writes like a typical...
T-SQL?
Yeah, the comparison is made with the IoT of SQL as well. It's very similar in that. So yeah, it's a good way of comparing that. But you could do very simple comparisons like anything. If I fire this, it will probably return nothing.
It would be really awesome if it did return something, because it does that blub.
Exactly. But to make sure that a demo would be a good demo, I prepared some queries already. Nice. So first off, like I just mentioned, it is possible to just query on a single property. It's important to note that when you're targeting specific digital twin properties, then those are most likely prefixed with a $sign. So in this case, I'm using the $sign DTID, which is the digital twin identifier. Which is cool, but we've talked about in the last episode that it's important that you model efficiently.
Yeah.
But it's also important that you only get the data out that you want, because you pay for the bytes that you're retrieving.
Yeah, so query efficiently.
Exactly. So that brings us to the next query. In that case, we want to do projection. If I will fire this, it will work. However, as it already states, there's nothing on my screen because that's now in the output, and unfortunately the viewer doesn't support it yet. So if I query that again, and then increase the view a little bit, you can see that I only have the properties that I specified in my select query.
Nice.
Yeah. So that is then a very simple query. Then there are also twin-specific queries that you can do. So like those are extensions on the typical SQS language. So one of those, for example, might be to get all the instances of a certain model out. So in this case, I'm interested in getting everything out that is of a certain model, in this case floor. So I just execute the query and I only get floors back.
Nice.
Yeah, that's the way to do it. But if you, for example, wanted to only get all floors out, but you have different versions, right? In that case, you can also facilitate queries like starts with, in that kind of sense.
Okay.
Which I have ready on the next line as well. And as you can already see, I'm using a $metadata model, and this is just once again, twin properties. So that's why I use that model, so or the $signs, which is cool. But now, for example, when we want to use our tags, right, that we mentioned in the first episode, we had that cool map where we wanted to add tags to define if a device is broken or not. In this case, nothing is broken.
Fortunately.
Good.
That's a good thing.
But what you can do is you can also check if something is defined. So even if the property is known on your model itself, it doesn't mean that you have to set it. So this can actually save you some data as well, right? So with these properties, you can actually check if it exists or not.
Nice. That's actually a good addition, just like you said, because it gives you room to optimize your data.
Yeah, definitely. So that's the first part. Yeah, of course, it also supports some selection functions like top and count, but that's very limited. And if we look at the where class, there are also more stuff like end with, is it string, is it number, is it boolean? The default, more default items. But that's fun and all. But now I've just got a few twins, which might be interesting, but we are overall also interested in hierarchies. So we want to basically join stuff. So in this case, I've prepared a quick query that is basically giving me a certain building with its floors. So what I'm doing here is a join. So what I define is basically, in this case, I give my first a query, which is digital twins, a name building.
Yep.
I join that with something that I call floor. And then I say related building.consists of. In this case, it's the building table. And the consists of is the relationship name that I want to join on. And then it works.
But you don't now see any relation between the two, because if you do select star, then it works. You get the hierarchy of the nodes.
Yeah, that is. I'm not sure if that's an implementation for the viewer or if that's the API, because I know by default that if you do select, you don't get relationships. That's a second query that you have to do. So I think that's really the viewer that's making it nice for you.
Okay.
If you do a join, there is a one big if. As you can see at the end, I do building.dtid. If you do a join, at least one of the items that you're using has to be a DTID. That's a requirement.
Okay.
Otherwise, your join won't work. So
But that's related to the fact that it's a graph-like database, right? Because then you need the ID to be able to identify the relationship.
well, it's the idea of the twin where you start.
Yeah.
So from that point, it will just walk up and down that. And it's also important to mention that if you do multiple joins after each other, there is a limit of 5, it joins in such a way, of course, that if it cannot find any twin in between, it will not show you the rest.
Okay.
But in a way, it makes sense. So now we've actually got some stuff out. We can now query in a little bit of hierarchy, but it would also be cool to get those relationships out.
Yes.
Right? There are a few ways to do that. First thing is you can use the SDK to just, if you have the twin, you can just get incoming and get outgoing relationships.
Okay.
But you can also query for relationships.
That's nice.
So instead of defining from digital twins, you would just define from relationships. And it will work exactly the same. But in this case, I have to put the output on again.
Because you can't visualize a relationship.
You can.
Yeah, but the viewer can't. I'm sorry.
Yeah, the viewer even can. I can show you that.
It does?
Yeah, I can show you that. But first, let me show you this query real quick. Because this one is going to search for relationships which have the contract ID defined.
That we had for the person leasing the
Exactly.
Yeah, I
So-
remembered.
Exactly. So in this case, I can find, so these two, in this case, source and target is a certain area and a certain tenant. So now I know exactly that's the relationship and this is the contract ID that I've mentioned.
Yeah, nice.
So in this case, if I would be searching for a certain contract ID, just execute it and we're there.
And it's fast.
Yeah, it's fast. Especially. But you have to mention, as you can see already on the top there, it costs something, which is my query charge. And you can see the more complex your query,
Yeah,
the
but
higher
of
the query
course,
charge.
that's related to how this works, right?
Yeah, definitely. So if I go back to doing the complete query again, I'll just turn my output off again. So if you want to check out, so here is the relationship that we have with our tenant. I can click on the node, but I can also, of course, click on the relationship.
Yeah, what I actually meant was if you don't have the nodes it connects, then just drawing a line doesn't really do anything.
No, that's correct. That
What
is
I meant
definitely
in-
correct.
It's hard visualizing just a relationship without the nodes it connects. But that's actually pretty cool.
Yeah.
There's even more in there than I remembered. So
But we're not done yet.
we aren't.
We aren't, because there's something very interesting going, and it might also confuse a little bit. So
Okay.
it's currently in preview, but they are currently adding match queries or graph queries. And graph queries are a way of traversing up and down of your twin with certain unknowns and certain properties. So in this case, I've written a query that is going to go to a building where I've defined the ID, and it's going to search for spaces where the sensor below it has a value above 20
Okay.
for the temperature sensor.
Let me check that. So the spaces and then the sensor. Okay.
But as you can see, right, so after the where class, you see quite some interest, or normal stuff, right, what we've seen
That's
before.
normal as SQL-like, T-SQL-like.
But then we see this cool thing before is the match. So this match is directly after the digital twins select. And there what we can do is we define how it's gonna walk up and down the tree. So in this case, what we said is we started building. Then we're going to go take a relationship that is going downwards because of the arrow in front of space,
Mm-hmm.
it's going to do between 1 or 2 hops.
Yeah.
So it can skip one or not, depending on what
Okay.
is in between.
Okay.
Then it is, when it has reached the space, it's going to go to the center, and it's doing a 1 hop. And in this case, if it's not specified,
It's 1.
it's 1.
Okay.
That's the default value. You can, however, do some cool things here. You can define the relationship here as well. So in those square brackets, you can say, this is my relationship name.
Yeah.
Then you can even add your relationship in your where and combine that to do an even more complex query.
Okay.
Or you could even put constrictions on the hops. So you could say it's only allowed to hop over certain relationship types, which can also
But
be
then stuff
one
is
or
really
different.
getting complex, right?
Yes. So that's why I chose for a rather simple query
Yeah.
still.
Yeah, I can imagine.
Then if I do this query, it will give me the spaces that have a temperature or sensor with underneath it that a temperature above 20 degrees.
Wow. This is powerful stuff, right? I mean,
Yeah,
this
definitely.
enables you to do virtually anything when querying your twins.
Yeah, definitely,
Nice.
definitely. Which is really, really cool. I really like.
I can see that you're enthusiastic about it. That's
Yes.
nice to see. Cool.
But for now, I think that's also where we should leave it for
Yeah.
this episode.
So what else is left? What's going to be in episode 3?
Well, we of course have eventing.
Yeah.
Like we've put a lot of stuff in the twin. Now we also want to get something out of it. And we also have some cool integrations which we want to talk about.
Oh, cool. Well, that's all up for episode 3. This was 2. Thanks so much for those awesome demos once again. Thank you for watching, and we'll see you next time. Bye-bye.
Bye-bye.